Hello everyone, and welcome to Chapter 2 of Project Skyblock. Today we'll be going over on how to automate farming in the game. It all started back in post-COVID 2022 when I built a sugarcane farm at the bottom of my private island. That was before a garden came along. Back then, we were allowed to use teleport pads to adjust our yaw and pitch. Now we have squeaky mouse mats, but this program will make all of them useless. Anyway, the sugarcane farm was just press D for 17 seconds, press S for 17 seconds, and repeat 15 times. Simple, right? However, ever since the garden is introduced, there are multiple types of farm, and the need to create an universal farming sequence came to be. First things first, a huge disclaimer. This bot demands constant human attention. There are many unresolvable circumstances that arise from game mechanics which are too complex for a bot to solve. For example, when farming in Hypixel Garden, one cannot expect an AI bot as of now to catch pests on its own. Hence, I am not responsible if you fail the macro check like Tesla drivers who watch anime while using FSD. Now let us get into the program. This is the giant header file that governs the entire bot for the Hypixel Skyblock Garden. As usual, there are the systems includes, and we also include the pause controller that we introduced in Chapter 1. Here is the first class in this header file, the farm yaw pitch class. It integrates the screenshot taking from MC Screenshot and a proportional mouse controller. In the private section, it has a lot of the similar constants as the MC Screenshot class. For example, char num and char width and char height. However, it only has 14 characters consisted of the numerical characters, the slash, the parentheses, and the negative sign. This is all it needed to identify the yaw and pitch. Next, it has some variables such as heading and set yaw pitch. The convention here is following the name with an underscore to indicate that it is a private variable in the class. This function here is just a remnant of the ship mounting code that was first written. This part is now integrated into the screenshot function. In the public section, we have this initializer function. This is very important because everyone in the program needs to use the same pause controller at the same address, and it is done when initializing the class. Different to the initializer which we will see in a bit, this initializer is built into C++. The initialize function loads the character images from the hard drive into RAM for template matching, and the save char function saves those files from raw images to be indexed later by the user. These four functions are thread save, reading and writing functions to change the yaw pitch and change the heading. The reason they are thread safe is to avoid data corruption and to avoid multiple threads that can change the set yaw pitch, which would never happen in farm. However, this is in precaution for future development. Here is the screenshot function carried over from the MC Screenshot class. However, it is simplified to only capture the yaw and pitch area. Also, it does not have the mask applicants method at the end. That is done here. The initialize function loads the character images from the hard drive into RAM for template matching. The save char function is used to save the character images piece from the screen in an arbitrary name. The user will later change them to match the character they stored. Here is the exact same image to chars function from the MC Screenshot class. As a reminder, it first finds the contours of each character, then extracts the bounding rectangles, filtering the ones that are not the correct size. Next, it sorts them to maintain the order of the text. Finally, it crops each and resizes them to the proper size. Here is the analyze charts function. It captures a screenshot, breaks them down into individual characters, and retrieves each character using the match_char function. Finally, it analyzes the string and extracts the yaw pitch data into a .2f structure. Because the yaw pitch class only needs to read the yaw pitch, everything is simplified and more integrated. The match_char function used here is much simpler and only includes the square difference normed method. This is because there were no errors in identifying numerical characters. This function moves the mouse according to the calculations. You could say that this is the actuator of the robot. It takes in a .2f object, move, storing the yaw and pitch in degrees. Next, it has some constants storing the ratios of the degrees to pixels. For my Minecraft sensitivity, I find that my yaw to mouse ratio is 3 and pitch to mouse ratio is 2. Next, it converts them to float. And this section essentially does is that if the movement needed is less than 1 pixel, then it sets that movement to 1 pixel, both for X and Y. And here we initialize the counters. This while loop moves the mouse, while counter X and counter Y are not equal to 0. It introduces dx and dy. If counter X is greater than 0, then it moves either a maximum of 5 pixels or what's remaining of counter X. Or if it's less than 0, then it also moves that. Else, the movement of X is 0. The same goes for Y. And here we decrement the counters, or else the mouse will move indefinitely. This section just sends the input information into the system and moves the mouse. Here is the main function of the class. It essentially acts as a proportional controller for the mouse. First, it requests that the other threads do not move, and initializes the class by loading the files. It reads the set yaw pitch to start, and while the pause controller is neither complete nor stop, it reads the screenshot and analyzes the charts. Next is the calculation part. It reads the heading and the set yaw pitch. It then calculates the movement needed to reach that target. In Minecraft, the yaw is given by negative 180 to positive 180 degrees. And this section ensures that the mouse moves the minimum distance possible. This if-else statement blocks the other threads if the mouse is not in position. Then it executes the movement. And if the main thread reaches a pause point, this thread also pauses, since it operates on a much faster tempo at approximately 100 milliseconds per cycle. The next one is the farm_this class. This is a base class for our farms, and everything inside here will be inherited. First are the variables. Protected means that these are all private and can be only visited within the class. Move time is for the player to move from one side of a farm to another. The slide time is for transitioning between parts. The input objects keyboard and mouse stand for keyboard and mouse respectively. Next are the pause controller, passed by reference, and the farming yaw pitch, also passed by reference. Next is this initializer, which is built into C++ to initialize the passed by reference objects. Here is an extra initializer which sets the move time and slide time of the farming object. It also initializes the keyboard and mouse inputs. First, in this class, we need to look at this random delay function. This generates a random delay between 50 and 150 milliseconds. This is to imitate the hesitation of a human player, and of course to prevent microchecks. Next is the key down function, which just presses down a key, and the key up function simply releases that key. The mouse down function holds down the left button of the mouse. The mouse out function releases the left button of the mouse. Next is the click key function. It simply just presses down a key, sleeps for a while, and releases the key again. Same for the left click function. The reset mouse function first chooses the farming tool in inventory slot 4. Then it requests the Pest controller to not allow the farming function to run. Then it writes the change set yaw pitch in the YP object. Then it waits for the YP to do its job and click the mouse. Here is a simple finish function that just beeps once to signal the player that the farming is finished. This is the core of the farm, the hold key function. For any Skyblock farm, the majority time is spent holding down a key, moving from one side of the farm to the other. And this is exactly what that function does. So first, it presses down the key. Next, it knows the starting point and calculates the time needed for the function to end. So while the steady clock is less than that duration, it checks for the Pest controller. If there is an emergency stop, then it beeps and releases the current held key and the mouse. It left clicks again because I have set my mouse to click clock. Then it outputs a message and returns. If a hard pause is issued instead, then it will note the time point, beep to signal, and stop farming. It waits for the pause to be cleared. Then it continues farming. And finally, it calculates the time duration of the pause and adds that to the already known duration. And finally, it releases the key. The seconds to wait time ratio is given here. It's approximately 63.574 ticks per second. Now the actual farming classes. The mega farm is used for wheat, carrot, potatoes, or knitworts. First, it has some constant storing the yaw and pitch directions it uses. Next is the initializer. The time for each run is 58.2 seconds, and the transition time between blocks is 2.7 seconds. The main sequence is that it first resets the mouse and farms one part. Then it transitions to the other part and stops there. If there is not a Jacob contest, then it sets a pause. And if there is a pause, it executes a function and waits until the pause is cleared. Now this section, there is frequently mistakes since I tend to land in the wrong spot. So in that case, I would just emergency stop and start again. The second part is the same. And here, the reset mouse is regardless of whether there is a pause, because when the second part is finished, the mouse direction changes. And here's the third part, and fourth part, and finishes. So in total, there are 6 types of farms. The mega farm, fungus farm for mushrooms, squash farm for melon and pumpkin, and cocoa farm for cocoa beans, water farm for sugarcane, moon or sunflowers and wild rose, and cactus farm for cactuses. All of these are essentially the same farm repeated over and over. Lastly, in this header file, there is the farm main function. This function is the main thread of the farming bot. It first asks the user to choose a farm, and notice here that for slightly different farms, I used a second number to denote the different types. So that's for squash farm and water farm. Next, according to the choice, it executes the corresponding sequence. For the mega farm, it needs a Jacob method. And for the mushroom farm, it also needs a Jacob method. But for the rest of the farms, since they are on a row-by-row basis, the user can pause whenever there are pests. The Jacob's method is not used. Then here is the keyboard listener. After the threads are initiated, the main thread is used to listen for user interrupts. The Boolean variable was pressed, stores two states, one of the emergency stop button and one of the pause button. In each loop, while the pause controller is not complete or is not stopped, it reads the two states of the keys and executes the corresponding functions. So for example, if the emergency stop button is pressed, it requests a stop. If the pause button is pressed, it toggles pause. Then it sets the new key states to the last key states. If there is an error, then it outputs an error message. Finally, it waits until all the threads are finished by using the join method. That is all for this video. If you would like to see my farm in Skyblock, please leave a comment below. If you enjoyed this video, please subscribe. I will be publishing part 3 very soon. Thank you for watching.